Logging from multiple sources. You will use Packet Tracer to view network data generated by Syslog, AAA, and Netflow. View log entries with Syslog. The Syslog server. Packet Tracer supports basic Syslog operations. The iOS devices in the topology are configured to send their log entries to the Syslog server. The Syslog server collects the log entries and allows them to be read. Log entries are categorized by 7 severity levels. Lower levels represent more serious events. The levels are emergencies 0, alerts 1, critical 2, errors 3, warnings 4, notifications 5, informational 6, and debugging 7. Syslog clients can be configured to send log entries to Syslog servers based on the severity level. Click the Syslog server to open its window. Okay, this is the Syslog server down here. Click and go service stop. Okay, service stop. Syslog. Okay, this is Syslog on. Okay, turn on the Syslog service. Okay, click here on. Keep this window open and visible. Here you will see the events, the logs. Enable Syslog. The devices are already configured to send log messages to the Syslog server. But Packet Tracer only supports logging for the debugging severity level with Syslog. Because of that, we must generate debug level messages, level 7, so they can be sent to the Syslog server. Okay, you receive it event from this IP 192.168.1.1. This is the date and time. You can see a belong mismatch, or double click here to view the complete message. And now you can see the belong mismatch and the specific port of the device. Click on R1 and command line interface. Click on R1, command line interface. Enter the command debug EIGRP packets to enable EIGRP debugging. The command line console will immediately fill with debug messages. Enter debug EIGRP packets. Enter. Okay, enable on privilege exit mode debug EIGRP packets. Enter. You will see the messages. Okay, events of the EIGRP protocol. Return to the Syslog server window. Syslog server. You will see the EIGRP messages here. The events of EIGRP. Okay, verify that log entries appear there, and after a few messages have been logged, click the radio button to turn the Syslog service off. Okay, click here on the server off. What information is included in the Syslog messages that are displayed on the Syslog server. We go to the Syslog server window and review, for example, this message EIGRP sending hello. Double click here to view the complete message. EIGRP sending hello on gigabit interface. The autonomous system one, the flags, the sequence. Okay, down here, receive it hello. Okay, sending and receiving hello messages. Some of the information is the type of EIGRP packet hello, the interface that received the packet, the EIGRP autonomous system number, timestamp for the message, and the source of the message. Okay, this is the timestamp. This is the autonomous system. This is the interface, and this is the source. So the destination is this IP address. Obviously, this is R1 because R1 is debugging EIGRP. So this IP address is R1. This source, if R1 is 11.2, this source 11.1 should be a neighbor, like another device using EIGRP. So go to R1 and press enter and use the following command on the bug all. Okay, this command on the bug all. All possible debugging has been turned off. Okay, very good. And on show running config, show run, space, space, space. You can see that the router is configured to send the log messages to the server. This is the IP address of the server, of this Syslog server. And also the router R1 is configured to send the messages on debugging level. Okay, remember debugging level is number 7. Log user access. Another important type of log relates to user access. Having records of user logins is crucial for troubleshooting and traffic analysis. Cisco iOS supports authentication, authorization, and accounting (AAA). With AAA, it is possible not only to delegate the user validation task to an external server, but also to log activities. TAGAX Plus is a protocol designed to allow remote authentication through a centralized server. PacketRacer offers basic AAA and TAGAX Plus support. When someone attempts to log on to R2, R2 will ask the TAGAX Plus server if that user is valid by verifying username and password. The server not only stores user credentials, it also logs user login transactions. Follow the steps below to log in to R2 and display the log entries related to that login. Click the Syslog server to open its window. Okay. Go to Syslog server, select the desktop. Okay, go to desktop, select AAA accounting. Okay, AAA accounting. And this. Okay, click on AAA accounting. Leave this window open. Okay, and click R2 command line interface. Go to R2. Enter the following user credentials. Enter username, use admin. Enter, and CCNP_8 is the password. CCNP_8. Enter. Very nice. This is the prompt. Use user exec mode. Return the Syslog server AAA accounting records window. Okay, click again on the Syslog server and you will see this. The date and time, the username admin, the IP address of the device of R2 is an active IP address of R2, and you access using the console 0. What information is in the log entry? Okay, is this information. The entry contains the timestamp for when the event occurred, the username used, the R2's IP address, a start flag. This is the start flag. The start flag indicates that the analyst user logged in at the time shown. Okay, you can go to R2, enable, show running config, and space. So R2 is configured with AAA, and the AAA authentication will use the login by default, and the group will be TACAX Plus. If TACAX Plus server is not available, do not use another service. Also, AAA is configured with accounting by exec default to send the accounting to the TACAX server. Where is the TACAX server? Is the Syslog server is also the TACAX server. You specified the IP address of the TACAX server and a key to authenticate with this server. Finally, the line console will use the default login for the authentication. And you can go to the TACAX server, go to Services tab, go to AAA, and now you can see the services on the radius port 1645, and is configured for R2 is a client, is a device with its IP address of R2. This is an active IP address of R2. Okay, obviously should be the gigabit 00 on R2. The IP address of gigabit 00 on R2 that is close to the TACAC server, gigabit 00 on R2 gigabit 00 192.168.12.2 192.168.12.2, the hostname R2, use TACAC service, and this is the key to authenticate to the client. The client is a device R2 Cisco secret, and on R2 is this Cisco secret. And finally, a username that is a person, admin CCNP _8, to authenticate to logging on the console line. Okay, very nice. On R2, enter logout command. Okay, go to R2, log out, enter. What happened in a AAA accounting window? Okay, go to Syslog server on desktop. Now you can see another log. Date and time, username admin, the flag is stop. The IP address of R2 on console 0. Okay, so a new entry was added. However, this time the stop flag indicates that the user logged out. Netflow and visualization. In the topology, the Syslog server is also a Netflow collector. Okay, also a Netflow collector. The firewall router is configured as a Netflow exporter. Click the Syslog server and close AAA accounting records window. Okay, go to Syslog server, close this. Okay, this AAA accounting records, close this. From the desktop tab, select Netflow collector. Okay, search the Netflow collector. Okay, is this? Click here, Netflow collector. Be sure that the Netflow collector service is turned on. Okay, be sure here is on. The service is on. From any PC, ping the Corp web server. Okay, this is the Corp web server. From any PC, for example, the PC22 command prompt and ping 209.165.200.194 to Corp web server. Ping 209.165.200.194. Enter. Okay, success. After a brief delay, the pie chart will update to show the new traffic flow. Okay, click Syslog server, and now you will see a different chart. And click here. Okay, click on blue. Now you can see the source was this is the IP address of the PC, the source, and the destination is the IP address of the server, 209.165.200.194. Okay, and counter packets 4. Okay, very good. Click the segments of the pie chart to view information about each flow. Okay, in this case, the protocol for pink, the protocol is 1. Okay, the another is also 1. The green, the yellow is 17, and the pink is also 17 for another protocol. Okay, what information is included provided by Netflow? The flow information includes the percentage of traffic that the flow represents, the source and destination addresses, IP protocol information, TCP flags, timestamps, and other information. Okay, also you can see the percentage of traffic. Okay, the percentage of traffic. The pie charts displayed will vary based on the traffic on the network. Other packet flows, such as EIGRP related traffic, are represented between devices. Netflow is capturing these packets and exporting statistics to the Netflow collector. The longer Netflow runs on a network, the more traffic statistics will be captured. Okay, so I guess this protocol number 17 is EIGRP, okay, between devices for a dynamic protocol EIGRP. Okay, but you can review the firewall. Click on firewall, enter enable show running config, space, space, space. Now you can see the IP flow export. The destination is the IP address of the Syslog server that is also a Netflow collector. The IP address of this Syslog server, and the port for Netflow service, the version for Netflow, version 9, and configure gigabit 00 and IP flow egress and gigabit 01 IP flow ingress. Okay. Gigabit 00 egress and gigabit 01 ingress. Okay, 00 egress, 01 ingress. Okay, because gigabit 00 is facing internet, insecure network, with gigabit 01 is facing the local network, the local area network. Thank you very much.